in a way, are modified pallets or individual pallets. They're great for floor storage. What they allow the warehouse manager to do, or the warehouse operation to do, is to increase floor stacking, because many products that are stored on these type of products cannot be stacked one on top of each other. They may be fragile like lamps, or they may be irregular shaped like tires, as shown in this slide. And what these portable racks allow you to do is actually do multiple stackings to maximize your floor space. This next slide is what they call an automatic storage and retrieval system, or an ASRS. It is probably the high end of the racking structures out there. These structures, or the rack itself, is built around what they call an automatic storage crane and retrieval mechanism, and is serviced by these. Loads can be either the unit loads that are on a pallet, or they can be mini loads on the system. Normally it consists mainly of upright frames and the horizontal beams. Now the shelf components or accessories are really a function of what's being stored in the type of crane. This one here shows some rails running back and forth. They could be decked over shelves. They could have risers where the machine just reaches in and drops a pallet on some kind of a riser bar. These type of racks may be located within a building, or actually the racks may actually serve as the building itself, with the roof cladding and the window cladding or the wall cladding and that stuff attached right to the racks. Height of these types of racks range anywhere from like 25 feet tall to over 100 feet tall. They require a lot of coordination. The installation of these racks, or the tolerances they are allowed to have, are much tighter than most conventional racks. And there is a lot of interaction between all parties involved in this building: the general contractors, integrators of other material handling equipment such as conveyors and stuff like that, and the person designing the floor slab, the electricians, the plumbers. There's a whole host, and a lot of coordination goes into these types of systems. This kind of concludes the slides I wanted to show of the different rack types, and they've given you the basic rack types. There are some specialty racks out there, and if you have that application, a lot of the rack companies do make some specialty ones, so you may just have to check around on that, or check with the Material Handling Institute or something like that, and they can give you maybe sources for your specialty applications. But before I leave the racks here, I do want to talk about other parties and concerns. This slide gives you a bunch of names there. You can read in building departments, the fire marshal, the rack installer, the crane and forklift manufacturer, and the list goes on and on and on. All these are part of installing a rack, and they should be considered when making a purchase. The building department, a lot of times there's permitting required, or after the rack is up, there's a post-installation requirement. The fire marshal becomes involved because the building sprinkler system has to be matched up to the product being stored. So in case of a fire, there's enough pressure there to handle it, or enough water, whatever. The rack installer is very important because when the racks go into a system, they must be positioned correctly within the building. The beams and stuff must be properly profiled per what the drawing says. And the racks must be installed plumb and square and shimming and anchored. So shimming and anchoring are usually parts of this whole process. These other people, again, like I said, it could be a coordinated effort, and all parties need to be coordinated on the work. And there's many times that the rack components are also used to help support some of these other components, like for example in-rack sprinklers. They're used to support conveyors and these other kind of things. And again, as you get down near the bottom, it seems minor, but issues like restrooms, power at the job site, trash removal, security, these are all important for installation of the product. Before I leave talking about the racks and maybe field a few questions, I do need to talk about the Rack Manufacturers Institute. As I jokingly like to say, leaving out the Rack Manufacturers Institute is like talking about federal income tax and leaving out the IRS. You just can't do it. The Rack Manufacturers Institute, or RMI, is it's a non-profit, basically trade association, which most of the U.S. major manufacturers are members of. It was founded in 1968. They're responsible for the publications of the design specifications for industrial steel storage racks. They have initiated an RMARC program, which basically says that member companies agree to design all their racks in accordance with the RMI specification. They offer load plaques, like you see here, to be in more conformance with today's national standards. They have a host of other materials on their website, as you can see from the website on this slide, that is well worth your time to go and visit. They have a free download of the specification, and they also have a frequently asked questions section. The members and the people who serve on this committee have many years experience and have put in a lot of time for these frequently asked questions, and definitely is a good resource to look up when you intend to buy a rack, or even if you're in charge of the maintenance of your storage racks. This basically concludes what I wanted to say about rack, and I think at this point in time, I think I have a little bit of time. I could field a couple questions if there are any.
Great, we do have a couple, so let's get to them. Number one says, which is better, structural racking or roll-formed racking?
That's a good question, and I hear it a lot. And I've been in the industry a while, and to me personally, I have no preference towards either one. They both have their little minor pluses and minuses, but to me they're both about equal. Now, there are people out there who will say that this is better or that is better, and they're entitled to their opinion, but from an engineering point of view, I think they both are about equal. And there's some advantages and disadvantages. Some people like the structural rack because they like that rigid connection look. The open structural shapes, they say, are easier to clean, more sanitary, so the food industry likes that, that kind of thing. And the structural shapes themselves are usually made of a little bit thicker steel than the roll form rack, and hence they're a little bit more resistant to penetration from a forklift or from the forks of a forklift if they happen to be run into. Other people do like the roll form racks, and there are advantages to those things too. For one thing, roll form racks, or companies that manufacture roll form racks, offer a greater range of upright sizes and beam sizes. So the capacity of your upright and beam can actually be closer matched to the actual project requirements there. On more complicated jobs, especially like the PIC modules, there are advantages of the roll form rack because it has multiple sides to it, which means connecting members coming in from different directions is a lot easier. And probably the most important is the installation of the roll form racks is usually considerably easier than for structural racks because the beams connect right into the uprights without the use of hardware, so you're not having to carry around all of this hardware. And later on, if a company wants to do a little reprofiling of upright beams, they like that too. But in summary, to me, I think they're fairly well equal. So I have no bias towards one or the other. Any other questions?
Well, this attendee has already been to the RMI website and noticed many member companies offer load tables for their uprights and beams. The question is, can I purchase the racking components that I need by using these tables?
Another good question. And the answer to your question, for the most part, or in many applications, is yes, they can be used. However, you need to keep in mind, when producing these tables, there are 3 criteria that are assumed, and those assumptions may not be true out in the real world, or in your project in particular. The number 1 assumption is that the racks are going into a non-seismic or non-earthquake region. Another assumption that you make is that the load on the shelves is a uniformly distributed load or evenly spaced load. It would be like caging in a shelf and pouring it over with water, something like that. So the load is uniformly distributed over the full shelf area. And a third assumption they make is that the spacing on the beams is equally spaced all the way up the system. And a lot of times all 3 of these assumptions are correct, and that's why I said yes. But there are times when these assumptions are not correct. First of all, let me talk about the seismic. There was a time when the only time people worry about seismic is if a rack was going to Southern California. Well, that's not the case anymore, and probably, I'm going to guess around a third of the United States area is now referred to as either medium risk or high risk seismic area. The second thing is that there are what they call point loads or concentrated loads that could be on a shelf. That would be a load that instead of being spread evenly over the entire shelf, or approximately even over the entire shelf, actually the load is very pointed, as if a container had legs on it. If you had a load, just an example, here's what's happened. If you have a load, and you can consider the load actually located dead center on a shelf and very narrow width, and it just sets on the front and the back beams, but in the center of the shelf, that load and its effect on that shelf beams would be the same as if you doubled that load and spread it out evenly over the shelf. So that's the effect of a concentrated load. The third thing is the spacing of the beams, and in many cases, yes, the beams are evenly spaced. That's including from the floor to the first beam and from beam to beam. But in many cases, they are not. Load tables for upright frames or capacities for upright frames are dependent on the spacing of beams. And there are many cases where these beams are not equally spaced. You may have a beam at the floor level and another beam up 10 feet. And that becomes a serious situation. So when you select your upright, what you really have to do is select the upright based on your worst combination of the spacing between the beams and the actual load that's in that portion of the upright. Another classical example of where the beam spacing are really critical is what they call tunnel or drive-through bays. And these are usually racks that have shelves up high, but they allow for a fork truck to cross from one service aisle to another service aisle without having to go back to the entrance point. A lot of times in these cases, the first beam may be at 12 feet, even up to 16 feet off the ground. And if these bays are located at the end of the row, the design of that very last upright really has to be taken into consideration, because the distance from the floor to that first beam can be very high, 12 feet. And that's a long ways if you can visualize it. Hope that answers your questions. I do think about my time's about up, so I do want to thank Global Spec for inviting me to present this session. I do hope it was helpful to you, the listeners. I do want to thank you for taking your time to listen to this presentation. Goodbye.
And thank you, Arlen, for taking the time to share your vast knowledge of storage racks. We certainly do appreciate it. Well, it has been a day packed with valuable information, from the latest advances in inventory management to selecting the right robot for your bin picking operation. We also learned how to reduce errors in your supply chain, and we finally found out the latest innovations in storage racks. At this point, I encourage your participation on the exhibit hall floor, where you'll find key exhibit booths manned by manufacturer product representatives, engineers, technical specialists, and other professionals from these organizations. As always, they've got lots of valuable information to share with you, such as new product releases, technology applications, video demonstrations, and a variety of materials. Remember, anything you may have missed from today's event can be viewed again via our online demand service. But the exhibitors are only here today, so spend some time with them while you can. And please take advantage of all of these opportunities. And don't forget to visit us right here at www.globalspec.com/events to learn more about upcoming online events that you won't want to miss. I'm Jim Brennan. I want to thank you for being with us today. We'll look forward to seeing you again at another Global Spec online event.